right, for this problem, I'm going to give you a brief overview of what an exponential model, linear model, and quadratic model look like and patterns you can see to identify those models. And then obviously if none of those models fit this table, then you're going to choose none. So for an exponential model, first let's look at what that might look like graphically. So for an exponential model, you'll have a graph that looks something like this. That is exponential decay right there, where the pattern decreases by a common factor, meaning you're multiplying by a number less than 1. Or you might have something that looks like this, where your values of y are increasing by a common factor, multiplying by a number greater than 1. A linear model is constant, so you're going to have an increasing line like this. You could have a decreasing line where it's decreasing at a constant rate. You could have a quadratic model, which is a parabola, opens like this, or opens downward like that. In order to figure out if you have a quadratic, you kind of have to find second differences is one way to do it algebraically, but you'll be able to see the pattern as you look at this table. So when we go over to the table, we see that 0, 0 is a point on the graph. Most of the time, if you run into 0, 0, you will not have an exponential model. So that tells me it might not be exponential. We notice that our x values increase by 1 and constantly. So what we can do is we can just find the differences here to begin with to identify if it's going to be linear or not. And what I notice is that we're adding 5.5 right there, and then we're not adding 5.5 again. So that takes out linear. So it's not a linear model. And so the next thing I need to do, let's double check the exponential. I mean, 0, 0 is possible if you have a exponential model shifted down to cross the y-axis. So what we could do is we could divide one y value by the previous and see what value we come up with. Well, that's going to be undefined. Go with 22 divided by 5.5, and we'll do 49.5. So this is checking if it's exponential or not. Just do 2 of these. Doesn't look like this is going to be a little less than 4. So this one here will be a little less than 4 if I type it in. This one will be a little less than or a little more than 2. So these numbers are not, these two values are not the same. So because it crosses at 0, 0, or has the point 0, 0 on it, I'd say it's not an exponential model. That mixed with the fact that it's not having a common factor. So it's either going to be a quadratic or none. And as I look at this, I don't see any patterns. Notice the y values are going to repeat. Now we could just be looking at a portion of it, but since I think I get 2 guesses on this, I'm going to say that it's not a quadratic either, just because I don't see this pattern following a quadratic pattern. So I'm going to try none. I very well could be wrong. Okay, and I am. So then because I eliminated linear and exponential, we're going to say it's quadratic. All right, not the best video I've made, but hopefully it helps you kind of see what's going on here. And what you'll find is that if you did plot these points on a grid, you would notice that, like right here, you would essentially be looking, let me do it in a different color here. If you plotted these y values and these ordered pairs right here on a grid, you would notice like it would cross at 0, 0, then you'd have 0, 5.5, and you'd notice that the increase models the right-hand side of this parabola. It just doesn't have anything on the left-hand side. Again, hopefully that helped.